Okay, we're going to go ahead and get started. We are going to do section 7.1 and 7.2 today. They're both pretty short, so we should be able to get through both of them. Okay, 7.1 is on different kinds of symmetry. Okay, and symmetry means that if you cut something in half, it's the same thing on both sides. Okay, so what I'm looking at, first of all, I'm going to actually skip number 1 because it has a different kind of symmetry. I'm going to go to number 2 and number 3 first and compare them to look at the different kinds of symmetry that we are seeing. Okay, the different kinds of symmetry that we're going to talk about in this section are being symmetrical with the x-axis, being symmetrical with the y-axis, and then being symmetrical with the origin. Okay, if you are symmetrical with the y-axis, like this on number 2, so this is your y-axis, and if you're symmetrical with it, that means the same thing is happening on both sides of the y-axis. Or another way you can look at it is if you could fold this like a sheet of paper on the y, both sides would lay on top of each other. Okay, so that's what we're seeing on number 2 is this graph would be symmetrical with the y-axis, because the same thing is on both sides of the y. Now, when you're looking at this bottom one, like number 3 on the handout, this one would be symmetrical with the x-axis, because here's my x-axis, and the same thing is happening on both sides of the x-axis here. Okay? Or in other words, if I could fold this like a sheet of paper on the x-axis, then the top and the bottom would again just lie on top of each other. I'm trying to get my screen right. Okay, so that's what number 2 and number 3 are showing. This one would be symmetrical with the y because it's the same thing on both sides of the y. This one would be symmetrical with the x-axis. Okay, those aren't necessarily too difficult to see. The other kind of symmetry that we're going to talk about is symmetrical with the origin. So here's my origin right here in the middle. So if you're symmetrical with the origin, let's look at number 1. This goes back to number 1 now. Here's my x-axis and my y-axis. So this is what number 1 looks like. And when you're symmetrical with the origin, and this one's harder to recognize because it's not just folding something in half and seeing if something's the same on each side. When you're symmetrical with the origin, what you have to think about is if you rotated this half of the graph 180 degrees, or in other words, turn this half of the graph upside down, it would lay on the other half of the graph. So it's not just in half, it's like you had to turn it all the way upside down. So if this part right here was rotated 180 degrees or halfway, it would end up lying on this side of the graph. So that's what symmetrical with the origin looks like. Okay, so that's what 1, 2, and 3 are going to talk about is the 3 different kinds of symmetries. Again, symmetrical with the X, symmetrical with the Y, and then the first one actually was symmetrical with the origin. Okay? Now, let's talk about sometimes you're called odd or even with your symmetry. So I'm going to write down what that means. Let me take a roll real quick. Okay, so I just took roll from everybody that's here. So if you are Carly or 15015, just say in chat what your name is so I can make sure I have you down. Okay, sometimes functions are called even functions or odd functions. Okay, if you're an even function, that means that you're symmetrical with the y-axis, like x squared, since squared is an even number, that's an even function, right? If you are x squared, you're a parabola or that U shape, which means, this is just an example of an even function, right? If you are an x squared graph, you look like this, okay? Which would be an even function because you are symmetrical with that y-axis. The same thing is on one side of the y-axis as on the other. If you are an odd function, then you're symmetrical with the origin. And an example of that would be an x cubed graph, right? Because cubed would be odd. And there's what the graph of x cubed looks like. So if you notice, if you rotate this part of the graph 180 degrees, it would lie on the other part of the graph. So that's what the difference is between an even function and an odd function. An even function is symmetrical with the y-axis, like the x squared function. An odd function is symmetrical with the origin, like the x cubed function. So the last two problems in this section are asking if they're even or odd. So let's look at what number 4 looks like. All right, here's what number 4 looks like, and it wants to know if it's even or odd or neither. So what you're looking at is, if it's even, it would be symmetrical with this y-axis. So is the same thing happening on the left side of the y-axis as is happening on the right side of the y-axis, which it is, right? So this one right here, since this, if I cut it right in half right here, it would be symmetrical with the y, which means this function is even. And the last one. Okay, so this one, again, this one's harder to see. It wants to know if it's even or odd. Even would be, it would be symmetrical with the y-axis. Well, if I folded it on the y, this is not going to lie on top of this, right? This would actually come all the way over here and not lie on top of this part of the graph. So it's not symmetrical with the y, which means it's not even. Okay, so now we need to check to see if it's odd, which would mean if I rotated this part of the graph 180 degrees and let it lie over on this side of the graph, would it lie on the other half of the graph? And it would. Again, odd is a lot harder to see than even. But if you did rotate this 180 degrees, this little hump right here, if I rotated it 180 degrees, would actually come and lie on top of that one, which means this one is symmetrical with the origin, which means it's an odd function. Okay, so that's actually all of 7.1. It's just those 5 problems talking about symmetry and whether or not you're an even or odd function. So that's all that 7.1 has. Okay, now I'm going to write some stuff up here for 7.2 and give you a second to write it down. Okay, and the way I'm going to explain this is actually the way that my college algebra teacher explained it very long time ago, and it has just stuck with me all these years. So I think it's a good way to explain it, and it's talking about what are the transformations of a graph? What makes the graph move up, down, left, and right? Okay, there's certain things about the graph that actually gives it its shape. What gives it shape is what is happening to the x, right? If the x is squared, it'll be a U shape. If it's an absolute value of an x, it'll be a V shape. If it's x cubed, it would be that shape that looks like that. If the x is in the denominator, it's going to be what's called a rational function, and we'll get into that in a minute. But what we're going to concentrate on today is outside of what gives the graph its shape, what makes it shift left or right or up and down on the graph. right, hopefully Wednesday we'll be able to get back on campus and we'll have to use this little board like this, but they can do with what we have. Okay, so what this says is that the inside numbers, and we'll talk about what inside means in here in just a second, are going to shift the graph horizontally, left and right. And I'm saying it goes opposite of the sign because if it's like a +5, it actually shifts it to the left. If it was a -5 on the inside, it would shift it to the right. The outside numbers, again, we'll talk about what the difference is between inside and outside numbers are in just a second. They're going to actually shift the graph vertically, up and down. But you're going to go with the sign on this shift. So if it's a plus, you're going to shift the graph up. And if it's a minus, you're going to shift the graph down. Okay? So let's look at what that talks about before we get into these. Let me show you what the difference is between an inside and an outside number. Let's say you have something that looks like this.
It's going down.
Inside would actually be what's inside the parentheses, or if it's a square root graph, what would be inside the square root. Those are inside numbers. Again, inside parentheses, or inside square roots, or inside absolute values. The outside numbers are the numbers that are outside of your parentheses or square roots or absolute values. That's the difference between inside and outside numbers. Okay? Inside, again, inside numbers shift you horizontally, which is left and right, but you go opposite the sign. So this would actually shift you to the left. Since it's +2, it would shift that graph to the left 2. This -5. Outside numbers shift you up and down with the sign. So since that's a -5, you'd actually be going down 5. This squared, that's what gives it its shape, right? That's what's going to give the X its shape. So that's going to be a U-shaped graph. Since it's squared, shifted to the left 2 and down 5 from the middle of your graph. Okay, so let's look at some of these. Like number 1. It says, describe how the given function can be obtained from one of the basic graphs, then graph the function. We have y equals x minus 8 in parentheses, squared. Okay, and then it's going to give you these multiple choice. The first part of the multiple choice says, what is the graph going to start off with? That's what's its shape going to be? Okay, so the shape is going to be an x squared. So you're going to start off with an x squared graph, which is a parabola, the U shape. Then you're going to shift it. Since this is an inside number, remember, inside numbers shift you left and right, but you go opposite the sign, which means it's going to shift this graph to the right 8. And I'll show you this. I'll share my screen here in just a minute to show you how to do this in Math Lab. So since it's -8, it's actually going to shift it to the right 8. So this would be x squared, which is a u, and then shifted to the right 8. So it would end up looking like this. Okay, I'm going to share my screen. And go to this problem in Math Lab. All right, do y'all see the problem now, or do you still just see like the homework assignment stuff?
Homework assignment.
Okay, let me see. I think I need to reshare it. All right, now do you see problem number 1?
Yes.
Okay, so this one says y equals x plus 9 squared, with the x plus 9 in parentheses. Which means, again, I'm going to start off with the x squared graph. And since I have plus 9 in parentheses, I'm actually going to shift it to the left 9, right? Because inside numbers shift you left and right, but you go opposite of the sign. Pluses actually shift you to the left. So I would start off by going to the one that says 9 units to the left, which would be D. And type in x squared. Then check that. And then it's going to ask you to graph it. So I'm going to click to enlarge the graph. So the first thing you're going to have to do, just like always, is tell Math Lab what shape you're trying to draw. Since it's an x squared graph, I'm going to use the x squared tool, which is the U shape. Now, on this section, you're not actually going to plot points for these kind of problems, except for one of them. You're actually just going, once I've told it I'm going to do an x squared graph, I just come over to the graph and click anywhere. It doesn't matter where you are. What it's going to do is put that x squared U shape on the graph for you. And then come down here, we're not ever doing any stretches or shrinking. It's always shifts, either vertical or horizontal shift. And you're going to tell it where to move that U shape. So since we're moving it to the left 9, so see what it's doing to the yellow parabola? All the way, oops, I skipped it, over to -9. And then save it. So again, you'll see that U shaped, and then it's moved to the left 9, and then you'll check it. Oops, what did I do? Okay. So it's actually going to just ask you what shape you're trying to draw. Then you'll click anywhere on the graph and just put the original one there. It's going to actually put the parabola right in the middle. It's going to put it right here. And then you'll go down and you'll tell it where to move it in this section. Okay? All except for number 2, which is what we're about to do right now. All right, number 2 says graph g of x equals x minus 9. Okay, so it wants to know what shape are you starting off with, since it's just an x. It's not squared or cubed or square root or absolute value or in the denominator or anything like that. If it's just an x, it's going to be linear, which means it's just going to make a line. Okay, so it's just going to make a line. So you're starting off with just the x shape, and then you're going to shift it. Since this minus 9, it's on the outside, right? It's not inside anything. It's on the outside. If you're on the outside, that's a vertical shift, which means up or down. So and I go with the sign. So I'm going to start off with the graph of x and then shift it down 9. Now, when you do this one, I'm not going to share this one, but when you do this one, since it is a line, you actually that's going to ask you to plot 2 points. So if you wanted to, you can actually, you can go to your y equals. And just type it in, x minus 9. You want to see it? So again, it's just a line that has been shifted down 9 spots. So if you wanted to get your points, just hit second table and then plot any of those 2 points, just like we always do to graph that line. All right, number 3. H of x equals 1 over x plus 5. And it wants to know, this is a multiple choice one, how is it going to be obtained from the graph of f of x equals 1 over x? So this is what's going to give me my shape, which is actually a rational function. Rational functions look like this. I want to know, what is this plus 5 going to do to it?
Left or right?
So is that an inside or outside number? That's inside anything, which means it's
outside, so it's going up or down.
Outside number. Good. So plus 5 means that's going to shift it up 5, because outside numbers shift you up and down, and you go with the sign. So when you're looking at these, that's just a normal one that hasn't been shifted at all. This one's been shifted up, and this one's been shifted down. So you would choose this one, since it would shift it up 5. Okay, now sometimes graphs are flipped upside down, and we've seen this before this semester. And what flips those upside down is that negative. Okay, so like if we had, so y equals x squared would be a graph that looks like that. This one would be the same graph, but it would be flipped upside down, which is not necessarily the mathematical term for that, right? Flipping it upside down doesn't sound very mathematical. What they call this is, if you have that negative like that, it's reflecting it across the x-axis. That's what makes it go upside down. Okay, so we're gonna have to tell some graphs to do this also, like on number 4. Okay, we have g of x equals, we have a negative, and then in parentheses, x minus 7 to the 3rd power, or cubed. Okay, so on this, let's see, what does that mean? Let's see, we're going to start off with x cubed. That's what gives it its shape. What's this going to do? It's an inside number, right? Inside numbers shift you horizontally or left and right, but you go opposite the sign. So if I'm going -7, I'm actually going to the right 7.
All right.
And then this is the negative that's going to flip it upside down, or in other words, reflect across the x-axis. So those are the 3 things that you're going to have to answer before you graph it. It's going to be an x cubed graph. You're going to shift it to the right 7 and then reflect it across the x-axis. So I am going to share this to show you how you would do one of these. Okay, so let's see this one. I'm going to start off with an x cubed graph. Since -11 is inside, that -11 is actually going to shift me to the right 11. And then the minus out front is going to reflect me across the x-axis. So let's see what that does. So shift it right 11 and reflect across x. So it'll be this A. So I'll tell it, I want it to be x to the 3rd power. And then it's going to ask me to graph it. So again, x to the 3rd power means you're going to come over here and do this x cubed tool. And remember, you're not going to plot points on this. You told it you want it to be an x cubed, so you just click anywhere. It doesn't matter. And it puts the x cubed graph up there. And then we just need to tell that x cubed graph what to do. Okay? So the first thing we're going to do is shift it to the right 11 units. So here's my horizontal shift. I'm going to go to see how it's moving the yellow graph to the right. I'm going to go to the right 11. And then down here, you'll have these 2 options that say reflect over X or reflect over Y. We're not doing any Y's in this section. We're only reflecting over the X. So now watch what happens when I click the reflect over the X axis to that yellow shape. It flipped it upside down. Okay? And then again, just check your answer to go to the next one.
Miss Hanson,
Yeah?
so I got a question. So as we're graphing, we don't need to press one of those, press on Math Labs. We don't have to press any line to graph it.
Yeah, you tell it at the very first step what shape it's going to be, okay? Which means on this one, the very first thing I did was tell it it's going to be that shape. And then after that, I didn't have to do anything. I just had to click on the middle of the graph and it put that shape there. Because what this section is trying to focus on is what these things do to that graph.
Oh,
So yes, you would tell it it's going to be an x cubed graph. And then just click anywhere on the graph and it puts the x cubed, this shape up there for you. And then you just move it.
okay. I gotta know.
Okay. All right, number 5. Okay, g of x equals x plus 2 squared minus 3. Okay, so it wants to know, what are you going to start with? Again, this is what gives it its shape. So you're starting with x squared. Then it says you're going to shift it blank 2 units. So that kind of tells you what you're going to do first. So this is what's going to move me 2 units. It wants to know which direction you're going to shift it here. So an inside number, shift you left and right, but you go opposite the sign. So since it's plus 2, I'm actually going to go to the left 2. And then it has a blank. Where are you going to shift it 3 units, which would be this move. So again, since it's minus 3, it's an outside number. So the minus 3 would shift it down 3. Okay, number 6. F of x equals the square root of x plus 9. So here's what the blanks look like. There's 2 blanks. This one will give you a drop down that'll say up, down, left, or right. So this is a plus 9. It's inside, right? It's kind of like the inside of the parentheses, but it's inside the square root. So that plus 9 shifts me left or right, but you go opposite the sign. So since I am plus 9, I'm actually going to shift it to the left 9 units. Okay, and then it gives you a multiple choice on this one. So the square root, the original square root graph just looks like this. So if I'm shifting it to the left 9, the one that's been moved to the left would be this B one. All right, number 7. Right, g of x equals x cubed, and then that minus 3 is outside of that cube root symbol. So that's an outside number. Outside numbers shift me up and down, and you go with the sign. So this one, since it's minus 3, it would shift that shape down 3. Okay, and the very last one. Okay, so here's your 3 blanks, and each one will give you a drop down. This first drop down is saying it has all right and left options. So the first move that you're going to make is the horizontal move, the left-right move. Okay, so let's see. Here the inside numbers are what shift you left and right. So if I'm going -5, that means I'm going to go to the right 5 units. Then it says across blank. So this right here, remember, that's what flips you upside down. Okay, but they call that across, it reflects across the x-axis. And then the last one gives you all up and down options. Okay, so here's my up and down number, right? The outside numbers shift you up and down. And so since that's +3, I go with that sign. So I'm going to go up 3 units. Okay, so that's all of 7.2. Okay, so I'll put this later in